Okay, so some other terminology that you need to know is the word face. So anytime we have a flat surface on a solid object, we call that a face. So for example, on this, it looks like 1, 2, 3, 4, 5, 6 sides. So that's a hexagonal prism. This right here would be one of its faces. I could highlight another one of its faces right here. We could highlight another one of its faces right here, right? And then of course, so any individual flat surface of this solid object. And then of course, there's two faces that are very special, and those are what we call bases. So this hexagon right here and this hexagon right here are what we call bases. So in a prism, there are two bases which are congruent and parallel to each other. So I want you to take notice that those two hexagons, right, they're exactly parallel, okay? Now, in a pyramid, there's only one base, and that's the base, that's the face, like this one. This is a pentagonal prism, right, because there's a pentagon base, and it comes to a point. So a pentagonal prism, okay? And the reason I know that that's my base is because every vertex of this base right here, let's see. Oh, I'm having a hard time drawing on it. So every vertex is connected to the point. And that's how I know that that's my base, okay? So we have faces, right, on both of these shapes. We can see this face, for example, right? But the base on a prism is two congruent shapes that are parallel to each other. The base in a pyramid is going to be the shape, right, the polygon that you see, where all of the vertices come to connect to the point. Okay, now there's some special other terminology. I'm going to erase this for a second. So we talked about the base. So now let's talk about lateral faces. So a lateral face is any individual flat surface of a solid object that isn't a base. So these are all lateral faces. Just like so is this triangle a lateral face. This triangle is a lateral face. This center triangle is a lateral face, right? Any face, any individual flat surface that is not a base. Okay. Now, that means that the lateral edges are any edges that are connecting two lateral faces. So when I look at this prism here, I notice that these two faces connect at this edge. So that's a lateral edge. This is also a lateral edge. So is this. We could also draw it in on those sides that are dotted because they're behind, we're not necessarily seeing it. So these are lateral faces because they're lateral edges because they're connecting two lateral faces, okay? However, this right here would not be considered a lateral edge because it is not connecting two lateral faces. It's just on the base, okay? Now, one thing that's going to be really, really important for us to be able to find in either of these to be able to know the volume is the height, okay? And I caution you that height is not always going to go from somewhere up high to some kind of like quote ground, right? It's not always going to be like that. The height you have to think about as a perpendicular distance. And in a prism, that height is just that perpendicular distance from one base to another. So any of these lateral edges count as the height. And remember, like I just said, the height does not have to be vertical. It does not have to be like this. The height has to connect the bases, and it has to be perpendicular. Okay? Now, with a pyramid, the height, again, has to be perpendicular. So in a pyramid, it is not one of these lateral edges. Don't do that because that's not perpendicular to the base. So in order to get the height of a pyramid, we would drop an altitude straight to the center of the base. Okay, so right there to the middle of the base, that perpendicular, right, that perpendicular altitude, that would be your height. So make sure that your height is always perpendicular. It should never be slanted. Okay? So the height is the perpendicular distance from the apex or the point to the center of the base.